This is the video for rail service integer programming routines. And here are the routines here on the left and on the right. First routine starts out setting NS to 5. That's a control register that's needed by this add list instruction down here, which is going to add 5 things from the one list to another. Next it says set the best index to 0, the best value to 0, and the test value to 0. Then it says for I of 1, and down here we have next I test count. Test count is 65,536. It's going to go around here a lot of times. It's going to set J to the gray offsets sub I. Those are the offsets that tell it what item to bring in or what item to take out of the solution. Add the test value, the gray data, at offset 2000 plus J. So it's going to put the value either in test value or take it out of test value. And here the add list, the add L action, is going to take 5 values from gray left, add to gray data plus J, and put it into gray left. Those are what we might call the requirements. Next, it says branch if less than or equal the test value to the best value. Well, if this test value is less than or equal to the best, well, it's no better than what we already know. So we're going to go down to CE and not do anything else about it. Well, if it is better than what we've had before, we're going to test it to see if all the values in gray left are 0 or greater. So it says for K of 0 to 4, branch if less than gray left plus K is less than 0 to CE. Well, it can't be less than 0 and be a good solution, so it goes down here and just goes around another loop. But if it qualifies, it comes down here and says set the best value to this test value and set best index to I. Well, that's the index of this loop where it's going from I of 1 to test count. Well, once it goes around here, when it's finished, it should know where the best value and the best index are. So we go to this other routine. Here it starts out filling numerically the 20 values that answer picks with 0, saying none of them are picked. Then it says branch if less than or equal the best index is less than or equal to 0 to CP. Well, that means it never found a best index. Remember up here it set it to 0 to start with, but if it ever found one, it had to be at least 1. Alright, so it found one. It continues down here, sets V to the best index. What it's going to do here is it's just going to take the index and pull it apart into its individual bits and put the value of the bit as 0 or 1 in result bits. So this is going to be a gray code number. We want to pull it apart and put in result bits each one of these for each one of the bits in best index. First thing it does, it goes in the loop, it sets result bits of I to V, and then it does a modulus of 2 on that value. So that value is going to be a 0 or a 1. Then it divides V by 2. Then it sets the most significant to I. It wants to remember the highest value of I that it found. And then it says branch if equal V to 0 to CH. That's over here. Well, eventually it's going to go to CH because it keeps dividing this value by 2. And it's remembering the most significant one, because that's important when we convert a gray code value to a binary value. Well, eventually we know V is going to become 0 and it's going to go over here. It's going to set U to that most significant bit that it found. The last time it found a 1. When we want to convert from gray code to binary, that most significant bit is always going to be on. We wouldn't start with a 0. We're going to start with a 1. We're going to fill the 20 values at gray bits with 0. Then we're going to set gray bits at offset U to a 1. Remember, we said that's the most significant one. Then we're going to subtract 1 from U. Then we're saying if U is less than 0, we're going to go to CK, that's down here. Otherwise, we're going to keep going around a loop here. To convert, what you have to do is you set your gray bits of U to the result bit of 1 away from U, and we add to it the 1 at U, and then we mod it with 2, and that gets you the binary value. It'll be 0 or 1 will be the value in gray bits at U. Eventually, we're going to finish here because U went below 0. Then we're here, we're going to say set L to 0, and to be frank with you, I have no idea why it did that, because I don't see it using L anywhere. So we'll forget about that. But after that, it says for I 0, next I 15, it's going to say branch if equal the gray bits of I to 0, to CN, don't do anything. But if it isn't 0, it's going to set the answer picks of I to a 1, meaning it picked that one. Alright, it'll go around here. Finally, it'll get down here. And at CP, it'll say set the answer total to 0. And for I of 0 to 14, if the answer pick is 0, it means it wasn't picked. But if it was picked, it's going to add its price to the answer total. So that's going to be the total of what was picked. And that's the end of the routine. So this is also the end of the video on rail service integer programming routines.